Great.
Okay. Let's see, can we unconfuse you? Let's go. So find the highest common factor and lowest common multiple of these two numbers. So first of all, we need to do our prime factor tree. I'm going to do it a bit small here because I'm going to try and fit it in before this question. So I know 10 times 126 is 1,260. 10 can split up into 2 times 5. 126, well, maybe that's, I know 2 goes in because it's an even number. Possibly 3 goes in as well, but we'll put 2 in. And I think it's 2 times 63 if I divide by 2. 63, of course, is 7 times 9. And 9 is 3 times 3. So let's just double check that they're all prime numbers here I have at the end. Yes, that's prime, 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 and prime. Okay, so they're all prime. All right, I'm just going to write out that final multiplication in order. So 1260 can be written, just don't want to run into my blue question. 1260 can be written, a bit too big really, I think. 2 times 2 times 3 times 3 times a 5 times a 7. Okay, so that's 1260, prime factor treed. 210 can also be split up into 10 times 21. 10 is 2 times 5. And 21 is 3 times 7. And they're all prime already, so I don't need to go any further. We found all primes already here. So that's right here. 210 can be written 2 times 3 times 5 times 7. Very good. All right, so that's the prime factors found. How do I apply what we did yesterday and find the highest common factor? So common. So I'm looking for common stuff in both lists. Not just now, Tony. The title is squares and square roots. Okay, so Eva, you know you left your camera on, therefore I can see you're not watching after asking the question about how to do this.
I'm watching. It's just that I already did all of that.
Oh, you've all this done. So to find the highest common factor then, all right, so in this list there are common numbers. 2 is in both lists. So once it's in both lists, I put it here in the common factor list. There is a 3 in both lists. So I'm going to put 3 in, I'm going to put a multiplication sign between them.
Mr. Collins, I think your camera is a little bit blurred.
No, don't worry. So 3 is in both lists. There's a 5 in both lists. So I multiply by 5. And there's a 7 in both lists. So I multiply by 7. And this will give us the highest common factor. So I can do this multiplication out. 2 times 3 is 6. 6 times 5 is 30. 30 times 7 is 210. So that is the highest common factor. Done. Now I do lowest common multiple. Now there's a few numbers left over which I have to use, but I also have to use the highest common factor. 210. The highest common factor is part of the multiple. And multiply then by what's left over. So we have a 2 here that wasn't circled, so multiply by that. And there was a 3 here that wasn't circled. So 2 times 3. Close, because you haven't multiplied it by the highest common factor. So I got to get 210 multiplied by 2 multiplied by 3. So it's got to use the highest common factor. Now if you have a calculator, you can use a calculator for this. Or you can do it in your head. 2 times 3 is 6, and 6 times that is 1260. So don't forget the 2 and the 3 are leftovers, but you got to multiply it by your previous, what you get for this. So that's why you always do the highest common factor first. So you can use it to find the lowest common multiple. So always go highest common factor first. No answers for blue yet? Do I see an answer in the chat?
I've only got the highest common factor.
Quentin. Okay, keep working on it, and I'm going to do it. I'll do it step by step, so you'll probably beat me to an answer. You can use a calculator for that hard multiplication maybe at the end. All right, so 7,040. Wow, it's going to be tricky. And 38,250. Yuck. Okay, so I know that 10 goes into this anyway, because it ends in a 0. 714 is left over here. Oh, I'm stuck. That's an even number at least. So an even number, I'm going to divide it into 2. 714 divided by 2 is, well, 700 divided by 2 is 350. So it's going to be 3, 5, and 14 divided into 2 is going to be 7. 357. I know that's divisible by 3. 3 fits in 1 with a 2, 9. 119. Okay, Virginia, let's see if you got the highest common factor. Type your highest common factor. If you got the highest common factor for blue, do type it in the chat to see if you're right before I write it down. Lowest common multiple is going to be tricky. Yeah, you're right. Yeah, both right. Yeah, yeah, all right. Very good. So 119. Then I need to split up and find what goes into this. Well, it ends in that 9. So that 9 tells me it could be divisible by 7. I think it is. 7 times something. 7 times 7 into 11 goes once with a remainder of 4. So it's going to be 1 and then 7 and 17. Oh, that's nice. They're both primes. So I have my primes here. 7,140 into primes. Oh, I haven't. No, I thought I was done. I haven't done 10 on the other side. Didn't do 10. 10 is up. 2 and 5. Okay, sweet. I got that for my first one. So 7140. Yes, Nikita, nice. That is correct. 7140 can be written 2 times 2 times 3 times 5 times 7 times 17. All right, so that's the first one. Second number, let's go with it. Do 10 again, I suppose. 10 times something, 3825 goes in. Okay, and 10 is 2 times 5, so I'll get that branch finished. 3825 then, oh. Well, I know it's divisible by 5 because it ends in 5. So 5 into 38 goes 7 times, with a remainder 3. 5 into 32 goes 6 times, with a remainder 2. And 5 into 25 goes 5 times. Okay, and also divide 765 by 5 because it ends in 5 as well. 5 goes into 7 once, remainder 2. 5 goes into 26 5 times, the remainder 1, and 153 is what we got here. Now you can use a calculator to help with that, those divisions. That's prime, so 153. It's not a prime number because I know that digits add to something divisible by 3. So 3 fits in. 3 goes in. 3 goes into 15 5 times. 3 goes into 3 once. 51 is also one of those numbers that I should recognize as not prime because it's divisible by 3. 3 goes in 17 times. 51 comes up a lot in these questions, you may notice that. All right, so I think I'm at the end of my trees. Very good. Multiply those out. 38250 can be made up of 2 times, that's only 2, yes, 2, 2, 3, 0, 5, 3 5s, 1, 2, 3, and a 17. Okay, let's look for highest common factor now. Would be numbers that are in both lists. There are 2's, one of them. There's a 3 in both lists. There's a 5 in both lists. And there's a 17 in both lists. If you multiply them out, you get 510. won't do that because I'm sure most of you haven't done this. So 510, and then the lowest common multiple then would be take this number, 510, and multiply it by all those remaining numbers that are not circled. 2 and 7 from this one, 3 and 2, 3 and these two 5s. 5 and 5. If you do all that multiplication out, you can do it with the aid of a calculator, you would get 535,500. And that is the lowest common multiple. Quite a large number. Well done, Nikita, for getting that. And well done, Virginia and Quentin and Nikita, for getting the highest common factor as well. Good stuff. All right, so let's move on to squares and square numbers and square roots. Okay, yes, good job indeed, Nikita. All right. So square numbers are quite important numbers. Well, I suppose they get their names because they're the length of a square. If you think about it. When we try and find the length and width of a square, if they're the same length, so 2 times 2, I know that the area of the square is then 4 units squared or whatever. That's why square, one of the reasons square numbers is used. So 1 times 1 is a square number. It gives me a square number. It is 1 squared, number by itself, which is 1. 2 times 2, 2 squared, which is 2 times 2 is 4. So this little 2 refers to squaring a number. Now we've done these, I'm sure you've seen this before. We did them a little bit in bed mass. Okay. Screen blurry again. Okay. Okay. So do have these in your notes because we're going to refer back to them. 4 squared is equal to 16. 5 times 5 is 5 squared is equal to 25. 6 times 6. 6 squared is equal to 36. 7 times 7. 7 squared is equal to 49. So I'd expect you to know them all up until 12. 12 times 12. You need to know those. They're the ones. Because they're in the times table. So you should know those answers. So they go on. I'm not going to write them all, but you can write up to 7. So I'll give you a second. There's square numbers. These are the square numbers. 1, 4, 9, 16, 25, 36, 49. They're formed by multiplying a number by itself. Now, square roots. So the symbol, you can see it on calculators and probably have seen it before, is this symbol here. It's a square root symbol. And square root is working backwards. It's if you have a square number, like 49, the square root asks the question, what number squared is 49? What number by itself gives 49?
So, for example, you would say, what is the square root of 36? And you just say 6.
Exactly, yeah.
Oh, okay.
So let's look at some examples. So the square root of 1 is 1. What number by itself gives 1? So that's what this means. What number by itself gives 1? That's what that means. Julie?
So it's like division.
A little bit, yeah. Yeah.
Okay.
Okay. So that means the next number I can get an even square root of is 4. What number by itself gives 4? Well, we know that, yeah, Brady, yeah. Good. Because up here we had said that 2 by itself gives 4. So working backwards, the square root of 4 is 2. So it's just reverse squaring. Okay. The square root of 9 then would be 3 for the same reason. What number by itself gives 9? It's like 9 is the answer, and we're trying to go backwards. The square root of 16, 4. The square root of 25, 5. What number by itself gives 25? So it's just the opposite of the list we created above. It goes on and on and on. What about the square root of, let's do a tricky one. Let's say the square root of 400. Now that's a tricky one. Anyone know the square root of 400? What?
Square
20?
No. 20, yeah. What number by itself gives 400? So something times something, and these two somethings have to be the same, gives 400. And that's the answer. So it's 20 times 20. 2 zeros make these 2 zeros, and then 2 times 2 gives 4. So yes, 20 times 20. So the answer, 20. Very good. Okay. What would a question look like with squares and square roots? Well, they can just combine a few into one question, ask you to evaluate. So, for instance, if I have something like evaluate square root of 16 multiplied by 2 squared minus the square root of 49 divided by 3 squared. Can we evaluate this? Now, order of operations would apply here. It applies everywhere in maths that you see operations. And remember, with order of operations, bed, mass, any brackets we deal with first. And now squares and square roots are part of the E, the exponents. So you got to deal with them first before you do any division and multiplication. So this is where squares and square roots land in the E of bed mass. So we got to do that if we have a question like that first. Square root of 16 is 4.
4.
Multiplied by whatever the 2 squared is, which is also
4.
Minus. I need to get the square. What's the square root of 49?
7.
7, yeah. Divided by
6. No. Yes, 6.
No.
9.
3 squared, which is
9.
9, not 6. It's not 2 times 3. Otherwise, it just would have written 2 times 3. Okay. So this is 4 times 4, which is 16. Take away 7 divided by 9. Well, that doesn't go in, but I can write it as a fraction. 7 ninths. 7 divided by 9 is 7 divided by 9. Like that. You're not going to get one with fractions because you haven't really done fractions yet, but yours will have whole numbers. But 16 take away 7 ninths. Does anyone know 16 take away 7 ninths? What would that be?
15 and
15 and
2 ninths.
2 ninths. Yes, exactly. 15 and 2 ninths. But that's a fractions question. We get to that later on in the year. But as long as you're able to get it to this stage, you could finish there. If you can't remember how to finish the fractions. All right. So that's squares and square roots. What about cubes? And cube roots. 3 multiplied by 3 of itself. Yes, Brady. So earlier on we had squares. Now we have cubes. So we have an extra dimension to the square. A cube. In other words, if you're finding the volume of this, you go 2 times 2 times the depth. 2 times 2 times 2. 2 cubed. So a cube number, for example, 2 to the power of 3 is not 6. It is 2 times 2 times 2. 2 multiplied by itself 3 times, which gives
8.
8, yeah. Bella?
Could you move the paper a little bit down, please? Yeah, thank you.
Okay. That's 2 cubed. 3 cubed is not 9. It is 3 times 3 times 3. 1, 2, 3. And that is...
27.
It sure is 27, guys. Well done. A few of you typing in the chat. 3 times 3 is 9 times 3 is 27. 4 cubed. Do you know what 4 cubed is? Yeah, try and write this down, Carlo. 4 times 4 is 16 times 4 is 64. You're right. I think it was Salome I saw in the chat. Oh, good, Carlo. Okay, we'll do one more. 5 cubed. 5 times 5 times 5.
125.
Boom, 125, yes. But if we can do, and this continues, obviously, they're the cube numbers. These are cube numbers. Same as the way 1, 4, 9, 16, 25, and so on were square numbers. And the same thing applies here as square roots. Cube root, can anyone describe with a microphone on how we write a cube root? Anyone know? We write it like a square root, but we put a little 3 here. Put a little 3 into the square root. So it's not square anymore. That's telling us it's a cube root. So the cube root of 8 means what number multiplied by itself 3 times gives 8. So what number multiplied by itself 3 times gives it 8?
Two.
Yeah, 2. So the cube root of 8 is 2. Now you're only going to be asked these numbers. 8, 27, 64, 125. They're the known ones. You're not going to be asked something that's not known. So the cube root of 27 is then 3. What number multiplied by itself 3 times gives 27? So it's the answers working back to find this number. So the next one would be the cube root of 64 is what number multiplied by itself 3 times 1, 2, 3 gives 64, and it is 4. Okay, so they're the first. Well, 1 obviously is still 1, but they're the main ones that are asked. Okay. All right, so make sure all that's in your notes. Okay, so I'm not going to give any homework on this. It is the last new thing for this unit. And if it's the last new thing in the unit, that means everything else from now on is going to be revision. And that means if we're doing revision, that means there's going to be perhaps an exam on the horizon. And there is. So the exam won't be next week. It'll be the week after next. Probably on the Monday of the following week. But we'll talk more about that and give revision on Monday. So there's no homework over the weekend. You may see on your manage back on Tuesday, we're going to have a little practice exam. That practice test is just going to be showing you what the test looks like. So it won't go on, no results will go home or anything like that. You can correct it yourself. The actual exam, it's not, I haven't confirmed yet. I just want to see how Monday goes with you all back on campus. So the 27th of September should be your maths exam, okay? So 27th of September on number. And I'll explain on this Monday, so that's the 20th, exactly what's coming up. I'll give you the revision work and all of that. So hopefully that does make sense. And we'll work a bit